Welcome to part 5, the last of this video series, where we will finally show how to build the application and run it on the EMSK and control your device from the Embark dashboard created for this demo. As mentioned before, you can use the IDE or the Windows command prompt to build and run the application, and in this video we will use the command line for simplicity. Before building, we need to enter some Wi-Fi and Amazon AWS IoT configuration in various header files in the application. So I'm going to open up my editor, and for Wi-Fi you need to navigate, it's not here, to board EMSK, to this emsk.h file, and this header file contains, there's board information as well as IP connectivity. And these two fields here you need to embed, which is a hotspot name and password. So you can configure your phone as a hotspot and use the values that are here, or you can replace this with your home or work Wi-Fi information. So it's a simple Wi-Fi password. The other file that you need to update is for the IoT configuration, and for that we need to navigate down to the application folder, is under FreeRTOS, IoT AWS Smart Home Demo, and open this AWS IoT Config.h file. And the parameters that you want to update are these parameters here. Now, in our case, this information matches the thing name on Amazon. These files are the names of the certificates that we've chosen. So here we just rename the certificates to the same name, so we don't need to edit any of this. The only information is you need to enter here your endpoint information. Okay, and again, this is detailed in the application note. Once you've completed the modifications in the AWS IoT config.h file, you need to replace the certificates in the cert folder. This folder needs to maintain this existing structure, and you should replace these three files and rename them to the exact name that you see here. These files are obtained from Amazon at the time of creating the certificate, and the Embark distribution comes with examples here that are empty, so definitely your application will not work if you use these, so you need to replace these with the certificates you got from Amazon. Once you're done doing that, you will want to copy this cert folder in its entirety to the SD card for insertion into the MSK. Let's do that right now. Okay, here's our SD card. Open the window, and then open your application folder in Explorer. Take the certificate folder and copy it over. Okay, so now we're going to insert the SD card in the EMSK like this. I'm gonna connect the power to the board, and finally I'm gonna connect the USB connection for my serial port access to my laptop, and the other end of the USB cable is just connected into my laptop. Okay, before we fire this off, let me tell you a little bit about the components on the board and how they're used in this demo. So we have a number of buttons. You see this left button here and right button here, and the button above the A in ARC. So these three are used to simulate actions like door lock and windows open and close. Be careful not to touch the R, which is a reset button, and the C, which is a configure button on the MSK, so this will just restart the device. There's also 8 LEDs above the buttons here, and the 0-1 pair will light up to simulate a particular action. The 2 and 3 pair similarly, and the 4 and 5 pair. So if I press a button, these will light up. If I get a command from the cloud, these will also light up or empty out. Now, when it's coming up all the LEDs will flash, and finally the LED 7 will be solid once the connection is established. And there's an LED here that you'll see blinking every 2 seconds, and that's just a heartbeat to tell us that the application is running smoothly. Okay, so let's go ahead and get this started. So I'm going to bring up here my command window. Now, to build this application, you'll want to use this command, which is make. You need to specify the board version. The default board is EMSK, so we don't specify board equal EMSK. That's default. Version is 2.2. This cur core parameter tells us which image we want to use on the EMSK FPGA bit file. And in this case, it's ARC EM7D and the toolchain that we're using. Now, in the interest of times, I've already pre-compiled this, so and I can show you by just running it again, but it's not going to build anything because it's already built. So when you want to run, you will invoke the same command, but with a run make target at the end, and that will tell the makefile to actually launch the application using OpenOCD. But before I do that, I'm going to connect my serial terminal. Almost forgot. So in this case, I'm using PuTTY. Here's the configuration I have preloaded just with the baud rate and everything. And the window came up over here, so I'm just going to bring it here. And so let's go ahead and run this. And then we'll zoom in on the board a little bit so you can see the activity as it starts to come to life. All right, so it's downloaded and application has started. It's trying to obtain, initialize the MAC, so this takes a little while, maybe 20-30 seconds. Once that's done, it'll get a MAC address, get an IP address, I'm sorry, and then the application will start, and we'll start seeing activity on the board with the LEDs. Okay, we got our IP address, certificates have been loaded, and now it's just initializing. And you can see LED 7 is lit up so that we've got a connection set up. And now we're starting to see updates on the screen. So this is communication between Amazon and the device. The J9 is flashing, so we're in a steady state. Now on the dashboard here, I can connect. It's telling me the connection is ready, and you can see I'm starting to get temperature updates, reading updates here. This is from this temperature sensor that we have, so I'm just going to put my finger on it to show you that it's doing something. As this is getting warmer, you can see on the split screen that the temperature is going up. You can see it in the on the graph and on the display there, of the half moon graph. Okay, so then the other activities is so on the board I can simulate, you know, by pressing this button that I've turned the lights on, and here this is the living room lights, and you can see the LEDs I mentioned that are lit up, and finally lock the door. Now you could see from the IoT device, this is the IoT portal. If I open my smart home object, I can refresh, right? And it's telling me here's the state of these devices, true, and temperature 27, pretty much what you're seeing across. So now if I want to, say, control these objects or devices from the dashboard, say I'm somewhere else, I can take an action over here and say, okay, unlock the door. And then the shadow state on Amazon is unlocked. If I go back over here and update, it will show that this is false. And you'll notice that the LED has gone off over here, right? So similar for the other two. I can change that state. The LEDs have gone off on the board, and you see the state change over here reflected as well. So that's how we simulate this communication between remote device in the cloud and using the portal that we've developed. So if you have any additional questions, you can post a question on embark.org. You can download the app note, download the code, and try this yourself. Thank you for listening.